Hello, my friends. Welcome back. In the previous videos, we talked about how we can optimize a design that we have with respect to the throughput and latency. And in the very last video, make sure that you rewatch it if you've forgotten about it. We talked about how we can optimize our design with respect to timing. And we discussed a few different methods that you can use depending on the design that you're dealing with that you can actually use to optimize for timing. The first thing that we talked about was to add register layers, right? And in today's video, I want to show you an example of how you can do that. So let's start coding. Um, let's get started. We go module and gives me everything. We don't really need the parameters. I want to keep it short and simple. So I'm just gonna go here and say input wire clock, right? And then we can have. I want to actually do. I forgot the name of the module. I want to do like a Mac unit, right? So let's not call it Mac, but let's go multiply accumulate, right? So it's small ac. So input wire, and then we can go heap on this 1 down to 0, and this is mul of 1. I like doing it this way because then it's like 7 down to 0, which is 8 bits. And when I look at this, it's just like instantly I know what I'm doing. And then I can just copy this and paste it 3 times. And output, right? And output logic. And this will be O data. And this will be mul 2. And then we can call this one sum operand. Not the most descriptive names, but you know what I'm doing. Anyway, so this is our port definition. Again, like I just want to keep it short and simple. So I'm just gonna go always flip float, which is always at pause edge of the clock, right? So that will be pause edge of clock. Begin. You can give it a label. We can. That's fine. It's up to you if you wanted to. So the first design that I want to do is like a very basic design, like the design which is not optimized. And I can just go boot data is, I get this guy and I put it here times. So the first operand times multiplied the second operand plus the sum operand. Okay. So this basically is what's going to happen at every clock. This is the operation that we're doing. We're multiplying 2 values and then we add the result to this guy. Okay. And then in the next clock, we will get the out data. That's cool. It works. But obviously this is not an optimized design. And the question is, okay, how do you want to make it an optimized design, like for timing optimization specifically? So I'm just going to split this to the right so we can actually see what's happening here. And I just want to copy the code so I don't type it again. And then I go here. And then here you can actually, if I go down, so here on the side, you can see like on the left, you can see the actual code that we had, like the original one. And then here, I want to show you the optimized one. So here, the changes that I want to make, because like the technique, if you remember, was to add register layers. So we want to add registers. So we want to define registers. We go logic, A-1 to 0. Again, do not be picky about like the bit width. Like obviously when you multiply these to 8-bit number, the result is going to be a 16-bit value probably, right? But we're not really caring about that. You know what? I'm just like showing the technique of how we can do things here. And so I'm just going to have this thing here. And so like I'm defining a register and I'm just going to call that multiplication temporary value, maybe that's what we call it. And then we go here, we have another one, logic, a minus 1 down to 0. And then we go sum temp, for example, right? And then here, I'm just going to go mul temp equals this, right? And then sum temp, we assign it to sum up, right? So this is like not really a sum temp, but it's like the delayed version of the sum operand. And then we can go, data gets the value of mul temp, right? Plus sum temp. Okay, so this is the same function. Like these two functions are identical. They do the same thing. And we're just like optimizing it for timing. So what's happening here is now in each clock cycle in the main code, if you look at this guy in here, at each clock, we are doing a multiplication and an addition. So you need to stretch your clock so that it can it has enough time to do all these operations. But here in this design, you're just like dividing it into smaller pieces, right? So in each clock, this is probably more time consuming than the add. So when you look at this, you're doing two operations, like a multiplication and a sum, right? Multiplication is more time consuming, obviously. So like it's a dominant factor here, but the point is you're just basically giving yourself enough time now by removing the sum operation here. So now you say in each clock, I just need to just multiply and the sum. So whatever the maximum is, that's going to define your clock cycle, right? Which in this case is obviously the multiplication. And just like that, like as simple as that, you can actually use registers, as you can saw here, and we added a layer of registers to improve the timing of our design. And so this was like a very, very easy example. You may look at it and be like, okay, sure, yeah, this was obvious, but it's actually not. Like when you look at some big design, people actually mess this up and just like put everything in one clock and mess up the timing. So this is the first technique that I wanted to show you. In the next video, I will be talking about the parallel structures, how we can use that in a design and take advantage of that technique to improve our timing. Hopefully you found this video useful. If you did, please like the video. It's going to help me a great deal. And if you haven't already subscribed to the channel, please do so. And I would really appreciate that. And as always, thank you for watching me. You guys have a good one. See you all in the next video. Take care. Bye-bye.